Friends, welcome back to the channel. If you have ever wondered how powerful the Intel Xeon processors are or how to calculate their performance in teraflop, then this video is for you. Today we will cover what actually teraflop means and how to calculate theoretical performance of any CPU. For example, we are taking here Intel Xeon Gold 6348 processor, and finally we will also show you how to benchmark it using High Performance LINPACK HPL library. So let's get started. So what is teraflop? We'll start with this question. So, before jumping in the calculation, let's first understand what actually teraflop means. So, teraflop stands for tera floating point operation per second. On teraflop, 1 teraflop means it is equals to 1 trillion floating point calculation per second, every second. So, scientific application like artificial intelligence, weather prediction, modular dynamic, computational physics, and CFD, computational fluid dynamics, finite elements, this kind of scientific software uses this, they are really required high teraflop performance for a better computing. So the higher teraflop, the more mathematical calculation your processor can perform every seconds. So today, let's discuss about this Intel Xeon Gold 6348 specification. We have taken this for example. Intel Xeon Gold is 528 core processor with 56 threads and base frequency is 2.6 gigahertz. It supports AVX 512, 2 FMA fuse multiply adds unit per core, designed for HPC high performance computing, virtualization and enterprise workload. In this calculation, we will see our base frequency. We have in this processor at 2.6 gigahertz because it's commonly used for theoretical peak performance calculation. Our server has Intel Xeon dual core 6348, which is a total 56 core processor. So now comes to the interesting part. Intel Xeon Gold supports AVX 512 instruction. What is this AVX now? AVX stands for Advanced Vector Extension. Instead of processing one number at a time, AVX 512 process multiple numbers simultaneously. A 512-bit vector can hold 8 double precision number. Each FMA instruction perform multiplication plus an addition at the same time. That means each FMA is equals to floating point operation. So in our example, Intel Xeon Gold 6348 core contains 2 AVX 512 FMA unit, as we can see this in this picture. Therefore, CPU core perform 8 into 2, which is equals to 32 floating point operation every second. Let's now move to the teraflop calculations. So let's see this, for example, as we have told, we have taken Intel 6348. Here we can calculate any processor with using this formula, which is simple. Just number of core performance we can calculate with the numbers of cores and frequency clock speed of the processor and flow per cycle, as we have seen in this previous example. We have this 32 flow per cycle, right? So if we calculate using this formula, we will get 2.33 teraflop with the single core processor. CPU with the 2 Xeon Gold 6348 will provide you 4.66 teraflop theoretical peak performance. We will also discuss now difference between R peak and R max further. Now let's see why performance is lower. So because what happens, whatever is theoretical performance, you will never get actual performance in your actual workload. What does it mean? So why your application will always will not be able to achieve 4.6 teraflop all the time? Because there are some application memory bandwidth issues, limitations, MPI communication, operating system overhead, and compiler optimization. Because of these factors, the real performance is usually between 85 to 95% of the theoretical peak. So measuring performance using HPL benchmark. The most popular benchmark is High Performance LINPACK application, or HPL. It solves a very large system of linear equation. The benchmark measure how many floating point calculation your system can actually perform. The result is called R max, which is achievable performance. Basically, R peak is basically a theoretical maximum CPU performance. We can see here we got R peak approximately 4.66 R peak. A good HPL should achieve this between 4 to 4.44 teraflop depending on your system tuning. Okay, and R max is basically achieve performance measured by HPL. So let's see this how benchmark works, how we can benchmark any CPU. First we have to download this, most probably if you have large machine like HPC or any workstation, you must be having this Intel One API or Intel MKL. These provide highly optimized maths library. First download this and then create hpl.dat file, and then we can run it, okay, with the help of MPI and MKL. So when you run, we can use this command MPI run minus NP56, or with your scheduler or whatever QBBS or slum you have. So you will see something like this. Suppose if you got 4200 this number G flop, so we can simply divide it with 1000. So the answer what we will get, it's a teraflop, 4.2 teraflop, right? So now let's understand what's the main difference between R peak and R max. Many beginner confused with these two terms. R peak is calculated mathematically and R max is measured by running HPL. If your R max is close to R peak, your system is well optimized. If it is much lower, if you see the huge difference in between this result, you may also need to tune your system. BIOS setting, NUMA configuration, MPI and memory and everything. So basically what is the main difference? Here we can see R peak is the theoretical peak performance, and R max is achieved performance measured by HPL. It's the real performance of your system. Okay, so now we will conclude with this As we can have see, we have used this Intel 6348 dual core, which is 56 core processor. Core core perform 32 flop per cycle with AVX 512 at a base frequency 2.6. Single CPU 2.3 we will get performance. With the dual CPU we got 4.66 RP. HPL benchmark shows the real performance R max expected 4 to 4.44 teraflop on a well optimized system. Thank you. Thank you for watching. If you have any query or question, please share your comments here. Thank you.